Good morning, everyone, and welcome to this NLA webinar on biomaterials. I'm Federico Ortiz. I'm head of content here at NLA, and I'm delighted to see so many of you joining us this morning. So we are really excited to present this webinar on biomaterials. This event is part of our Net Zero program, but also we are very excited that we're also part of the London Climate Action Week. So for those of you who don't know much about NLA, we are London's built environment community. We bring together politicians, professionals, and the public to discuss, debate, and share information about key issues and topics in the built environment industry. Our home is the London Centre, as you can see here in my virtual background. So if you haven't been to the London Centre, please do visit us at the Guildhall in the city. And if you're not a member of the NLA, please do join us. Check nla.london for more information. You can access more events like this one, conferences, reports, exhibitions, and business critical industry insights. And for as little as £20 a month, you get access to a lot more of this content. So today, we will hear some of the latest advancements in biomaterial research and the opportunities, challenges, and solutions for wider adoption. We've been discussing already and sharing some interesting information. So we have quite a lot of interesting things coming your way. So I'd like to remind you that there will be time for questions when I come to you, to the audience at the Q&A moment. So you can use the Q&A button here on Zoom. And that's all for me. We're going to start with a few presentations. So I'd like to introduce Savannah Willitis, PLP Labs team lead, who will be presenting the research on mycelium. So over to you, Savannah.
Good morning. Thank you for the introduction. And yeah, so my name is Savannah Willits, and I'm the team lead for PLP Labs, which is essentially the research and development arm of PLP architecture. And we look at emerging ideas on the periphery of architecture and design. Let's see if we can go to the next slide. I'm gonna have you go next slide, please. And there we go. So we, the last 2 years, have been experimenting with mycelium. And we have engineered a way to combine 3D printed wood with mycelium. So the picture you're seeing here was taken at Clerkable Design Week, where we debuted 85 of these 3D printed mycelium blocks, which was quite cool to do. And we all did this in-house. And I'm also, this research is forthcoming. So we just got accepted to present our research at the International Conference on Structures and Architecture. So a lot more is coming. And we're finishing our research just this summer. So a lot of things are pretty exciting in the future. But first, I'll have you go next slide. What is mycelium? Well, mycelium is the underground network of fungi. So mushrooms would be the fruit or the flower of fungi. Mycelium is everything underneath the ground. And the way that it functions is that you've got like how do you grow it? You've got spores from a mushroom, and then you have a natural substrate, so like hemp, sawdust, something for the mycelium to eat. Then we package it into a 3D printed wood mold. We grow it in big black boxes with a cup of water for about a month, 3 to 4 weeks. Then we dry it in a heating chamber for about a day or two at 40 degrees Celsius. And then ta-da, you've got a block. And because it's completely biodegradable, the wood and the mycelium, it can biodegrade. And if you throw it out into the forest, maximum in 6 months, it will go back to the earth. I'll have you go next slide. And because of this, it has really good, has a pretty low carbon impact. So Grown.bio, who is, I believe, based out in the Netherlands, and they do packaging, based upon their calculations, their carbon impact per liter of packaging is negative 0.5 kilograms. And this is just expended out when they look at all their packaging. We're currently in the process of doing our own carbon calculations for our process because we do use energy for the 3D printer in our process. but we're still pretty confident that it's not going to have a major carbon impact. All right, next slide. And so with mycelium, it has a lot of interesting properties. The first of which, it's very lightweight. But despite being lightweight, has a high compression strength for its weight. So in December, we were able to go and test some of our samples at the University of Cambridge in their fatigue engineering lab with CNMI, which is Center for Natural Material Innovation. And we found that at strength at 25%, which basically means that 75% of the original height of our sample, it could hold just over 400 tons of force. And for reference, if a blue whale is roughly 150 tons, it was holding like just about three blue whales, just about. The densely packed sample did even better at 568 force of tons. And our 3D print which was about 3.7 blue whales. And then our 3D print didn't do it just as well for the compression strength, rounding about at 270 tons of force. But I will say we also looked at a 3-point bending test, and the 3-point bending test, which it looks at tensile strength, did much better with the 3D print. I will say when you compare this, it's comparable, mycelium is comparable to an adobe brick. It's just lighter. It's not as comparable to, say, concrete. We still wouldn't necessarily recommend it would be in a load-bearing capacity just yet. So that's something to consider. I'll have you go next slide. And with that being said, there are a couple challenges that comes with mycelium. The first is consumer trust. Initially, we found there's a lot of consumer interest. I wouldn't be speaking today if there wasn't. But then when it comes out to choosing a product, we find that people don't choose mycelium. We also find that it's not as durable, especially if you're touching it and moving it around quite a bit on a daily basis. It does have an initial high production cost, and it's a discontinuous process, which means you do have to grow it. So we grow our blocks for about a month in-house. There are people like Ecovative or Magical Mushroom Company out of London who can grow within their process within a week, but still it takes time. And because it's a biomaterial, not every mycelium sample is going to look the same. So as you see on these slides, there's all these different samples, and all of them have their own look and own quirks. And there is a slight odor. So if you do smell the mycelium, it will smell a little bit like mushrooms. All right, next slide. That being said, there are a lot of opportunities for mycelium. So again, there's a lot of interest. It's very lightweight and biodegradable, which we talked about earlier. It's a really good insulator. So that's what mycelium does best. It fills in gaps and just fills up the space. It's biophilic and it's pliable. So when I say it's pliable, it means that you can grow it in a range of geometries and shapes. If you have basically anything you can mold or cast, you can grow mycelium within it, which is quite handy. There's quite a lot of people doing cool things with mycelium or fungi in general. This was taken from MycoStories. And if you look at the materials aspect in the top right corner, there's a lot of players in the products and packaging sphere. This is because there's not as many regulations or restrictions when it comes to packaging as there is compared to architecture. But that being said, that doesn't mean there aren't people who are working with architecture and mycelium. So next slide. The people who come to mind, especially in the UK market integration, is Blast Studio. They're based out in West London, and they do really great mycelium sculptures that then they basically ride around on their bikes and pick up recycled coffee cups, sterilize it, and then use that as a substrate for their mycelium. Then there's Mogu, based out of Milan, who do a bit more practical things with mycelium, looking at floor tiles, acoustic tiles, all sorts of things you can put in the office, which is on the market. There's also a bit more interior products, such as furniture and lighting. When it comes to actual architecture, it really, as it stands, remains more on the pavilion installation side, as you see here, like what we did. But I do say this with a caveat, because earlier this year, Red House Architects based out of Ohio created the first self-standing house made out of mycelium, and that was built in Namibia. So there's quite interesting things happening in the sphere. It's changing every day. But I think overall, mycelium has a lot of potential, not the best for load bearing capacity, but for say for like insulation or for other types of uses, it might be a bit better as a biomaterial potential, I'd say. But that is just the general overview.
Excellent. Thanks, Savannah. That's really, really great. It's really exciting in terms of all the possibilities there. So now I'd like to introduce our second speaker today, Dr. Natasha Watson, who will be presenting Bureau Happel's work with Hempcrete. Over to you, Natasha.
Cool. Thank you very much for having me. I actually focus a lot more on embodied carbon, but I've been asked to talk today about Hempcrete, so I'll be focusing on that. But if you have any questions about sort of wider embodied carbon, very happy to answer them. All right, so hopefully the next slide will. There we go. So this is an image of, I would say, one of our hero projects where we managed to use Hempcrete. The product, hemp lime, is the non-sort of product name for it. This is the Wales Institute of Sustainable Education in North Wales. If you ever get the chance to go and visit, please do. Everyone there is lovely, and also there's some really exciting things going on there. What I hope to do in these 7 minutes I've been given is give you a brief overview of hemp and other biomaterials for construction and how it can benefit your projects in more ways than just being sustainable, because I think that's the really key thing to try and get more of these materials used in our everyday. So a quick definition of what bio-based means. Typically means from a living organism, also mycelium. But in construction, it broadly means sort of plant-based at the moment. So either from trees or from crops such as bamboo, hemp, and straw. Bio-based materials can form many different products, from insulation made from hemp or wool fibers. I'm kind of moving from left to right on the screen, to panelized systems such as EcoCookon, which is a structural panel system made up of softwood and straw bales. Straw and timber, sort of in situ straw bale construction as well. The image of the two people at the bottom, that's actually from the Centre of Alternative Technology, where the Wales Institute of Sustainable Education is based. They're building their straw bale theatre there. You can also sort of use it for blockwork infill panels, such as with hemp lime. And I'll give a little definition of hemp lime later. You can also, sort of increasing in density, have flooring systems. So that sort of really cool image at the top there is a plywood system with really densely packed hemp fibers in a resin to form a really cool flooring system. You can also get things such as obviously timber and glue laminated timber, cross laminated timber, but you can also start to get things like bamboo laminated lumber as well. And then moving on to sort of cladding materials. So that kind of carbon style one at the top there is actually it's a carbonized bamboo facade. And then at the bottom on the right-hand side is a corrugated hemp facade panel that's produced by a company called Margent Farm. And that's a hemp farm in Cambridgeshire. And it was used on the Margent Farm house, which was put together by Practice Architecture and Material Cultures. So if you don't know about that project, please look at that. So a quick definition about hemp lime. It's the woody stem of the hemp plant is taken, dried, chopped up into 50 ml pieces, and then mixed with varying proportions of lime mortar. Not cement mortar, it has to be lime mortar. And it forms quite a solid material. So the proportions of the hemp to lime can be adjusted to improve either its insulative properties, so lower density, you add a bit more hemp shiv, or its structural properties, so higher density, and you add more lime. So moving on, focusing on sort of hemp pros and cons. Obviously, I'm going to start with the pros. A hemp and lime mixture is actually breathable, hygroscopic, and can provide thermal mass when the density is higher. So this is one of the really key things about hemp lime, is that it can passively buffer internal environments, greatly reducing energy costs if it's designed with correctly. And I've got a couple of case studies to show you later. It's also renewable and recyclable, so it can actually, at the end of life, if it's hemp and it's lime mortar, be chopped up and mixed into the ground. Hemp as a crop doesn't require fertilizers, inhibits weed growth, and actually aerates soil. So it's really good as a rotational crop. With farming, typically you can grow crops on soil for 3 years in a row, and then every 4th year you need to have a rotational crop to kind of return the nutrients to the soil. So hemp can be used as one of those rotational crops. It can, when you use it as a solid hemp lime wall, and I'll show you some examples later, be a really simple construction that can provide air tightness, weather tightness, insulation, and then also protect the timber frame that you use to construct that solid wall. And also it can be low embodied carbon as well. I haven't actually included any figures because it's been very tough for me to find an EPD, Environmental Product Declaration, that I'm comfortable sharing, and they do vary a lot. However, because it is a crop-based material and you grow it specifically to use it in buildings, you can take advantage of that sequestered carbon. And so it means that it can be really, really low carbon, and in some circumstances as well, can be considered negative embodied carbon too. Moving on to the next slide. So next bit, the cons, unfortunately. As with any material, you're going to have cons. The curing time for solid walls really does depend on thickness and climatic conditions, but it does take approximately 4 weeks for that to cure completely. There is still a lot less precedence for its use in comparison to other materials, which within a very sort of risk-averse construction industry that we have, can really increase perceived risk for the material, which kind of starts to stop conversations before they're really had. And also our supply chain is still quite small, so it doesn't fit in with certain contracting practices of needing multiple quotes for different materials. Right, moving on to the hemp lime benefits. So this image is of the Hempcrete Museum store in Wroughton, which is held by the Science Museum to keep some of their artifacts. This is research done by the University of Bath and a couple of other partners as well back in 2015. This was where loads of different sensors were put in to really measure that sort of temperature stability and relative humidity stability to see if hemp lime can be used as a much more low energy way of protecting and looking after artifacts and, items of special interest that are susceptible to things like mold and temperature fluctuations. So the construction costs for this particular store were around about 10% higher, but the running costs were less than half of that of a similarly built but non-hemp lime climate controlled space of the same size. What they did find is that there were minimal fluctuations of relative humidity or temperature when the mechanical systems were off, and then when the mechanical systems were on, the fluctuations were greatly reduced. Making full use of this kind of buffering effect can only work if the hempcrete or hemp lime is exposed to heat and humidity to buffer it. So it needs to be exposed or maybe finished with a clay or lime plaster, or potentially even sort of timber slats sat slightly further away so they're not on the hemp lime itself. This is the Bureau Happold project that actually sparked my PhD, the Wales Institute for Sustainable Education. They actually used hempcrete, the product, in their flooring. So they had perlite insulation, hemp lime floors, plywood, and then ash floorboards on top. And then also they used it in 2 different ways for walls. So they used it through sort of spraying hempcrete on a skeleton of studs in a way that sort of took a little bit of time to spray it on in the amount of layers that you needed. And then there was also tamped hemp lime walls as well. So you put up temporary shutters, you put in your hemp lime mix and you compress it, and then you sort of do that in various different lifts as well. The tamped method actually was more successful for than the first. The sprayed method, they found, tended to lead to a large amount of wastage, which is a bit of a shame. But you know, this is what the Wales Institute for Sustainable Education wanted to do. They wanted to learn all the different methods of actually constructing with hemp lime. The external walls are 500 mil thick and achieve a U value of 0.14 watts per meter squared Kelvin. So, hemp lime for beginners. Hopefully you joined this call because you want to learn how to build more with hemp lime. I would suggest 3 things. Use hemp in products that can be easily substituted for others, things such as hemp fiber insulation, and potentially using hemp lime blocks as well for if you need to have sort of block infill walls, because that way it kind of de-risks all the different things like what kind of shuttering do you need? How can you ensure that the people on site are actually constructing it in the right method? Those kinds of things. Secondly, don't use hemp just because it's sustainable. You must emphasize the technical and economic benefits of the material. It can passively regulate your internal spaces, greatly reducing energy. So really sell it on that. Also, it's a big shout out to the Alliance of Sustainable Building Products. They're very knowledgeable in this area. They're very friendly. So please, if you are interested, reach out to them and speak to someone who is really trying to push for these materials to be used further. And my last slide, biomaterials for the future. If we can't imagine a better future, it's very difficult to get there. So I like to imagine a world where we can pretty much build all buildings out of 100% bio-based materials. Can we use rammed sort of driven timber piles for our foundations? Can we use bamboo lumber for our structure? Can we use seaweed-based plastics for our windows? You know, all of those different things. How much of a house today could we make using bio-based materials? And then also on the right-hand side there is a hemp lime vault from the Centre of Alternative Technology. So a load-bearing structure made out of hemp lime. And I thought it was very cool. So I want to include that. So thank you very much.
Excellent. Thank you, Natasha. I think, again, that's really, really great and really exciting as well in terms of another type of biomaterial. I like that point. And yeah, don't just say it's just sustainable and really going into the benefits. So we can come back to some of those in our Q&A, in the panel discussion. So I'd like to remind everyone listening to us today that you can put some questions on using the Q&A function. But now I'd like to bring all our speakers together, and I also like to introduce Ellen Willis, Thrive Sustainability Consultant at Chetwoods, who's joining the panel. So Ellen, thank you very much for joining today as well. And I'll start with a question for you. So both Savannah and Natasha mentioned a little bit on this, some of the challenges around kind of accreditation of these biomaterials, and then issues around kind of regulation and in particular, I think, fire safety. So how can we overcome some of those challenges, and what's needed in a way, what's our ask as well to overcome those challenges?
Great, tricky question. Hi, everybody. I'm Ellen Willis. I'm a sustainability consultant and architectural assistant at Chetwoods Architectural Practice. And my work encompasses many facets of sustainability, but I focus on more sustainable materials advocacy and research. So really excited to join here to try and untangle this very knotty question. So overcoming challenges related to accreditation and regulations and fire safety really requires a multifaceted approach. And I think education is a crucial first step. As both Natasha and Savannah mentioned in their presentations, it's essential that we inform stakeholders about the numerous benefits of biomaterials, beyond reduced carbon emissions to decreased waste and enhanced health and well-being, amongst others. And leveraging existing resources can help avoid redundant efforts. It's already been a shout out to ASBP. I second that. They've got some fantastic resources. We don't want to be reinventing the wheel. And at Chetwoods, we've engaged in various educational and material advocacy initiatives to help further education on biomaterials in this industry. So we've influenced sustainability related filters on NBS source. We've beta tested 2050 materials. We share weekly Materials Monday posts on social media. But I think my favorite part of my job is running Material Matters workshops, which are basically a crash course in embodied carbon, and introduce a range of more sustainable material alternatives, many of which are biomaterials. And so as stakeholders become more informed, we're going to be much more likely to be able to demonstrate a market desire to adopt these materials. Secondly, in my experience, multidisciplinary stakeholder collaboration is essential and incredibly powerful. One of the things I'm working on at the moment is a research project looking at enabling structural timber in the UK logistics sector. So it's quite niche, but a lot of these learnings can be translated to many other materials and other sectors. And this initiative brought together developers, project managers, engineers, consultants, occupiers, insurance professionals, competitors, collaborators all together in one room for a really enlightening discussion. And we'll be publishing a report on this later this year. And this level of collaboration means that we can really identify what the real barriers are and what challenges are already solved. And then we can focus our efforts on where they're most needed. In terms of fire safety in particular, obviously a crucial issue, especially in the post-Grenfell construction industry. One of the biggest issues around fire is insurance. So early engagement with insurers is definitely very important when planning to incorporate biomaterials. Interestingly, my research on timber in particular has shown that insurers are often just as concerned, if not more concerned, about water ingress and repairability. So I think there is a level of misconception around fire and biomaterials to a certain extent. And there are a couple of anecdotes that I'd like to share. So there was a building owner that I was chatting to, and one of their buildings unfortunately suffered a small fire, remained standing, and the charred timber columns retained their structural integrity. The building owner now sort of shows it off as a feature as to demonstrate the durability and the fire resistance of timber. And secondly, I was talking to an architect a little while ago, and they designed a school with a full timber structure. And as usual, there were concerns about fire, but instead of changing the material, the architect chose to approach the design in a bit of a different way. So they designed a circulation so that a full evacuation in the event of a fire could be completed in a matter of seconds. And I think that demonstrates that one of the ways to overcome these challenges is to think outside the box a little bit and see, especially with my architectural background, what design solutions can be implemented to help overcome these challenges as well. And I think that really a lot of this boils down to cultural and systemic change, which is so challenging. And what I mean by that is sort of how do we align and define our priorities and values, and how do we update our systems to then align with that belief system? And that's no small feat, but obviously, as we've seen today from the wonderful presenters, there's so much exciting innovation happening, and I'm confident that with educational events such as this one and the right collaborative attitude, that these issues will be overcome.
Excellent. Thank you very much. So now we'll bring together all our speakers. I think, the more we can also see, I think the examples in real life, no matter how small they are, I think that also helps. But Natasha, Savannah, I'd like to extend that question to both of you as well. What do you think in terms of kind of overcoming some of these challenges? Kind of where to start?
You want to go first, Savannah?
Sure. I think when it comes to this, I think it's being honest about the opportunities and the challenges of bio-based materials, and being pretty upfront about it, and having that in demonstration with the pros and cons of typical materials, because we can't keep building like we are. It's just not an option, given the climate crisis. So I would say start there. But I also want to echo everything that Ellen just said. I think that's absolutely spot on. And it's just so true.
Yeah, I mean, what can I add? You know, this kind of idea that things like timber aren't durable. Well, we've got timber houses that are over 100 years old in the UK. You can't really say that. So it's that kind of, it's almost like we've forgotten just 2 generations worth of knowledge and that craftsmanship, because of how warped our construction industry is now. A lot of the examples that I gave are from a long time ago. The Wise building was built in 2010, and it's like there was this really good there were really good vibes around sort of new sort of low carbon materials, etc. And then something happened, and we started building more and more buildings for profit rather than for people. And as soon as that happens, the incentives and the purpose of what you're building changes. And then it isn't really about things like well-being, or dare I say it, sometimes about beauty or things like that. If you're building a building to make money, it's about what are the minimum standards I have to build this to so I can get the maximum payback. And hopefully we're coming out of that because of things such as biodiversity net gain, this emphasis on, granted, it's about embodied carbon at the moment, but I'm really hoping it will sort of expand to all the different other facets of sustainability and regenerative design that we should start to include. But it's I've just gone off on one, but it's I think that
Yeah.
it's a really big topic that we need to really try and address. Like, what are we building for? If we're building for profit, then maybe some of the conversation should be around that. Should it be a case of, actually, if you use hemp lime, your energy costs can reduce because it can passively regulate internal temperature and humidity, and we sell it on that. So yeah, it's
No, I think that's super interesting. I think it's that, yeah, bringing on board clients, this insurance kind of sector, but also obviously policymakers. So obviously we're in a very special year with, well, we recently had mayoral elections, but also we have elections coming up. So if you had to ask for one or two, or how many you want, kind of changes in terms of regulations and policies that you think would accelerate the adoption of biomaterials, what do you think would be, yeah, a good kind of ask for the next government of?
Put Part Z,
yeah.
get Part Z in place, first of all, embodied carbon regulation, mandatory whole life carbon assessments, and then follow that up with some embodied carbon targets. Once that's in place, I think that's going to kick off a whole lot of innovations into lower embodied carbon materials. That's the big one, I think, from my perspective.
I think so. What you've seen in France is that they're targeting, is it 50% of public buildings need to be timber, and they've just gone ahead and done it. And what you need is, you need clear, such as Part Z, you need clear clear goals, clear rules in place, because the kind of softly approach doesn't necessarily work. People argue against it, and things then get sort of watered down. I think what our planning people have done in London, definitely, where they're using sort of, you can't get planning permission unless you tell us the embodied carbon and have it achieve these kinds of numbers, is an amazing way that people working in planning have taken the sort of control that they do have to try and force these things through. And you see that happening in lots of different local authorities as well. Sort of Baines have adopted embodied carbon targets for, so Bath and North East Somerset, for people who don't know where that is, for embodied carbon. But yeah, if Part Z was to come in, everyone would have to achieve that. And if we were to have something like all buildings need to have 30% of renewable, like, products by weight in them, that will create change. But I don't think we're going to see something as clear cut as that soon, even though I'd like something like that to happen.
Thank you.
I'll,
Savannah?
I'll have to echo both Natasha and Alan, their points for sure, but also to add something other, like with the material regulations, there's a sense that the building regulations also have to adapt to biomaterials, because as currently the regulations are based upon like concrete and steel, typical materials, and we're penalizing biomaterials for not performing and not being traditional materials, when in fact they were never going to be. So I think that needs to be a cultural systematic shift on how we test and what we could deem safe or secure enough to be in our buildings, given the benefits that biomaterials have that have been pointed out during this entire talk.
Yeah, absolutely. I think that's a really good point. So we have quite a few questions coming in, but I'd just like to ask one more, and then I'll take some of those. So I think the other challenge or the exciting thing here is how to scale up some of these projects, right? So we're kind of in testing phase in some of those, but we have some good examples as well. And obviously we have kind of different biomaterials presented today. But if I ask you in terms of scaling up, what would you like to see kind of in terms of next steps? And I'll start with mycelium, start with Savannah.
I'd say based upon also the people we've talked with like Mogu and Blast Studio and Osmos, that scaling up is quite a difficult process with mycelium, that it actually might not be the best material that you scale up, especially in the use cases for mycelium. But that also being said, there are a lot of other biomaterials that would be perfect for scaling up. So I'd point that, but I would put a little caveat being like, what are we scaling up for? Is growth actually necessary? For housing, absolutely. We're definitely in a housing crisis. We need more development in that sense. But then there's the other question of what purpose does this development serve, and what purpose does this type of building serve when we have a lot of buildings that can be retrofitted for the modern age.
Yeah, that's a good point. And Natasha?
I mean, agree with what Savannah's saying. I would say one way to scale up things such as hemp would be to start to replace insulation with hemp insulation, start to replace concrete block infill with hemp lime block infill, that kind of stuff. I think that because I think that those can be, in certain circumstances, a very easy way into using bio-based materials that is kind of like unsexy or anything like that. But to be honest, we want them to become run of the mill. We want them to be default. So I would say that that's my way of scaling up appropriately. Also, we can take full advantage of the fact that, yes, we need to retrofit more, because things like hemp lime are a lot lighter than concrete blocks. Mycelium is a lot lighter. So when you're doing sort of vertical extensions, or if you're changing the use of an existing building, not overloading what you have already in terms of weight is really important. So therefore, it's another string to the bow for bio-based materials to really take advantage of the fact that we are going to retrofit more.
Want
Yeah, I
to
think it's a
echo
really
that
good point.
completely.
Yeah. I think that's very interesting on retrofit and kind of repairing maybe on existing buildings using these biomaterials. I think that sounds really exciting. That kind of relates to a question that we have here from Sophia. It was for you, Natasha. If you see Hempcrete being used in high rise and also low bearing in the UK, there was an example in France of a 7-story building built using Hempcrete in wall construction, but not in low bearing capacity. So I guess that kind of response by would you like to
Yeah. Again, it will depend on what your fire strategy is, if it's life safety or if it's fire for replacement of goods. But I can see hemp lime being used for non-load bearing infill walls for high rise personally. I actually don't think we should be building too high because very high rise buildings are actually quite poor performers for embodied carbon more generally. You're dedicating a lot more structure to resisting wind loads and your foundations. So you're actually using many more resources for the same amount of same amount of floor area than if you kept constructions a lot lower. And then also there is a school of thought of a Goldilocks density of construction, which is around about the 6 stories mark, where you've got appropriate density for liveliness, for bus routes, that kind of thing, but you're not so high rise that you kind of lose that human scale. So I would pair that with, I can see it being used in higher rise, but actually I think that we should be building more sort of buildings that max out around about 6 stories anyway.
Yeah,
kind of caveated.
I think that's very interesting because it's you're also saying that somehow by rethinking the materials that we're using, we're actually really rethinking why we're building. So I think
Agreed.
that's very, very strong. I think that's very interesting.
I also want to add like rethinking like what we build as well.
Yeah.
Like this is Natasha said, like if you reimagine a house made of only biomaterials, or maybe a city made out of biomaterials, the way we urban plan, the way we build, and what we build has to completely change. And I find that really exciting, a different type of urban planning paradigm.
Yeah, absolutely. I like to pick one of the other questions on Hempcrete. So in terms of Raoul is asking constraints of growing and using Hempcrete in the UK. Are there, and maybe let's use this question to talk about other examples as well. Other countries, so globally, how are we doing in terms of use of Hempcrete, but also mycelium? So examples in other places where we're seeing, well, hemp mass produced. I think maybe it's quite a lot, but if you like to, if we see that happening in the future.
I mean, I need to do more of a study on it, but in terms of conditions to grow hemp, the UK is fine. If it's a rotational crop that arable farmers can grow every 4 years as standard, I think that would be a really good path to ensuring that we have the right quantities. I don't know how well it grows in other climates other than sort of like the European, Northern European kind of wet, not too hot kind of climates. But to be honest, it makes sense to grow what grows well in those climates. So in more sort of tropical climates, does it make more sense to grow things like bamboo and actually use bamboo as your main bio-based material in those circumstances? I would say that rather than thinking hemp can save the world, it's a case of really looking at what is indigenous to those areas, what thrives in those areas, because that way you don't need to try and force fit something that is much happier growing in a temperate climate into a tropical climate. That kind of radical localism of using the materials that thrive well in those locations, and then the vernacular will start to change and really be of its location, which I think is also a wonderful way of imagining how the future should be as well. So,
excellent. Helen, or would you like to comment on some of those?
Yeah, I mean, I completely agree. I find it fascinating how this sort of conversations and a lot of these questions does come back to this like radical reimagining of what we want our built environment to be, what we want it to look like. In the research that I've been doing on structural timber and logistics, we've come across the exact same problem, that part of the resistance is that we're trying to take a standard steel warehouse and just build the same thing out of timber, and obviously that's not going to work. And so, really looking at your materials, what you have available, what you want to use, and starting from there and letting the inherent properties of the material lead you, instead of trying, and let that open yourself up to more opportunities. I think that similarly, as we're saying, we need to be looking at benefits further than just reduce carbon emissions. The opportunities are massive to increase people's quality of life, the way that we live. I think that it's, you know, when we let go of the sort of market norms, there's so much really exciting opportunity there. And it's really exciting to hear that talked about.
Great, thank you. And Savannah, would you like to mention any other examples across the world that we've seen on mycelium or other biomaterials?
I guess the first thing I'd say is, well, we're seeing things in London with like Osmo Studio, or like just the UK in general, Osmo Studio, Blast Studio, who are doing really cool things in terms of sculptures or objects in interior products within architecture. You're seeing Mogu with the ability to bring mycelium into the office environment. And so, and there's of course Ecoative in the States. So there's a lot of, like, would say, interest and beginnings when it comes to mycelium being part of architecture in general. I was actually going to say something more off of Ellen's comment, but I forgot it. So we'll
We
stop
can come
there.
back to it.
Before but if I remember, I'll jump in.
Yeah, absolutely. Please do. There's a question here around, because we've been talking kind of about construction materials for buildings, using biomaterials for this. But how about road construction, street projects? So other parts where we mostly use concrete, I guess, where we could use biomaterials. So yeah, do you have any thoughts on or material recommendations for these types of projects?
Well, actually, I can jump in on that because in the Netherlands, they had been making street signs out of mycelium, which is pretty cool. And in that context, it can make a lot of sense. And I did remember just a comment from just adding on Natasha's point with the localism and the importance of localism when it comes to materials. I think that is a strength of mycelium, because as it currently stands, the most common mushroom that's used for mycelium is reishi. But that's not to say there might be other strains of mushrooms from around the world that might be better in this context because they've had this evolutionary progress where they are perfectly suited for that context. So you can use a local mushroom for a local spore for local mycelium that will have the properties for that landscape that for that context, which is quite exciting, especially when you consider or reimagine on-site production for buildings.
Yeah, absolutely. That's a really good point. Natasha, any other uses for Hempcrete?
As in more sort of infrastructure rather than
Yeah.
buildings.
I mean, probably not roads. Well, who knows?
Yeah, I would say that things like road surfaces, maybe not as well suited, because I mean, I think anything that can reduce the amount of concrete in a road surface is good. So, you know, more maybe you could go down more of an earth-based route, so kind of compacted sub-base, things to actually increase permeability, so you've got a bit more sort of drainaways. At the moment, well, ones that I've seen, I'm not an infrastructure engineer, but ones that I've seen of like standard buildups, a lot of them include like a 100 mil, 150 mil thick slab. I'm like, why do you need the concrete for all of those contexts? So I think trying to reduce the concrete content of current road buildups is probably the path, rather than trying to get hempcrete into road buildups. I think that's the kind of question to ask, rather than see if we can put more hemp in infrastructure projects.
Yeah, but also it's going back to that point. Now you totally sold. But at that point around, because we're thinking that we want the same type of roads for the same cars and trucks and everything that we're using at the moment. So again, it's like, is it actually what we want going forward, the type of usage in terms of roads infrastructure in this particular case? So it's going back to, yeah, what's the future that we actually want there? I wanted to ask a question to all of you around another kind of side of the opportunities in biomaterials, which has to do with skills and jobs for the future. So it's kind of about, it would be nice to hear as well how you got into this in a way. So yeah, if I start with you, Ellen.
Yeah, absolutely. I mean, I was fortunate enough to be raised by a climate science editor in my wonderful mother. So I feel like I've got sort of outrage at the climate crisis in my bones. And I studied architecture, but to me, architecture was always sort of a vehicle for sustainable change rather than a pursuit of sort of a particular aesthetic or anything like that. So I have sort of two hats on really as an architectural assistant and this huge passion in sustainability, and have managed to find a really quite sort of innovative job role to apply both of those things together. And because it's such a niche, I have quite a lot of seniority and I've made a lot of progress and am able to, call myself an expert and speak at events like this relatively early on in my career. So there's so much opportunity for learning. It's very surreal to be in a position that I am and speak on panels like this and run workshops with planners and developers, etc. So I think the opportunity there is great, and there's so much upskilling that needs to happen, and it's the sustainability industry is only one that's going to grow. So all positive things, really. I think it's fantastic, and if you've got generally, from my experience, if you have a passion for it, there's such a need for it that you'll learn as you go, and you very quickly pick it up and become, very knowledgeable.
Mm-hmm. Excellent. That's really, really exciting. Savannah?
I say one of the great things about mycelium is that nearly everyone can get into it. You can buy a mushroom growing kit and do it in your bedroom. Like, it's so accessible for so many people. We're doing it in-house in a meeting room. Like, it can be very low tech, and really can be for everyone. And I'll say, like, how I ended up in this realm was actually have the props to the team here at PLP, where I had started and they were already doing experiments with mycelium. And shout out to Abinok, who had done his master's thesis on mycelium in earthquake zones. And he had brought mycelium to his interview here at PLP, and they had just run with it. And I will say, like, unlike Ellen, and I love the fact that your mother is like a climate science editor. That's fantastic. In my personal context, I'm from the States, in a state where 50% of people don't believe climate change is real. And yet, at the same time, I was raised in timber-frame houses, and 60 to 70% of the state is public land. So you have this kind of dichotomy of being very close to the land, and yet coming out of a culture that is in denial, which I think is a really interesting place to be contextually here in London, where I have the ability to speak and advocate for the use of biomaterials.
Thank you. And Natasha?
Yeah, so I always liked science and art, and that kind of led to me becoming an engineer. And actually, I did my PhD because I couldn't get a grad job. It was 2010 when I'm showing my age now. It was 2010 when I graduated, and the construction industry was still suffering from the 2008 financial crisis. And so I actually fell into this. It was a paid 4-year PhD, but it spoke to me. It was like, well, that sounds quite interesting. And I've got the grades, so let's go for that. And it's probably the best thing that's happened to me. It really put into words all the things that I think I'd been thinking about, but hadn't quite been able to focus time on. What I did find, though, is when I graduated, it was still sustainability, and especially sort of embodied impacts of materials was would like to have, or that'll get costed out, or those kinds of things. And it has taken, I would say, Architects Declare in 2019 to really sort of snowball everything into becoming conversations like we're having today, embodied carbon targets in planning. And even now, I realize that there are still people who think that to have a sustainable building, it needs to look like a hobbit house. You can't have modern architecture. You must sort of live in a hair shirt. It's that some people still think that that's what a sustainable building is, but actually, you have so much scope to reduce the impact of your buildings today by doing simple things like reducing your structural grid by even half a meter if you can make it work. Really addressing things like structural loading, or really sort of pushing for the reuse of a building rather than building new. And it's still trying to communicate that to people that really drives me. And what I'm finding more and more now is that actually, rather than necessarily the technical aspects of what I do, it's seeing it sort of click in someone's eyes that really drives me. And I love that have been able to kind of meander through my career, but kind of have some guardrails for it. So I know I'm broadly going in the right direction, but I try not to define it too much, because this like whole area is changing so quickly that you have to be kind of adaptable and kind of see where there are gaps in why it's not quite working, or where is the golden thread. And for me, it's finding those gaps and going, actually, this is the like pragmatic action you can take so that we can all just have a better built environment to live in and thrive in.
Brilliant. That's amazing. Thank you very much. I think that's a really good way to finish this webinar. We have a few minutes left. I just would like to say thank you very much to all our speakers today. These were really great presentations. I think we have quite a few things that I like to follow up with everyone here today in the call. So we'll share some of the links and things that were mentioned today, so you have access to all that information, because this is really about sharing knowledge. That's what we would like to do here at NLA. And this is really, really exciting moment, I think, for biomaterials. So really hopefully we'll see more of them in the coming years. But yeah, thank you very much for joining us today. Have a lovely weekend. Bye.